All right, today we're going to talk about sum and difference identities, and these have to do with more trig. So before we get started, we need to go and review some basic trig values of common angles in radians. So here's our radian values: 0, pi over 6, pi over 4, pi over 3, pi over 2. And those have common angles associated with them in degrees, and you can convert them if you have to. But you should you memorized this once before, and you are going to need to know them. So just so you know, be aware that that is coming back, right? That's coming back. So trig values, useful, awesome. So now what I want to talk to you about is the sum and difference identities. And this is what they say. They say cosine of x minus y is going to be equal to cosine x times cosine y plus sine x times sine y. Okay? And you're like, Miss Moss, why do we need to have this identity? Because isn't that just cosine x minus cosine y? Well, that is technically not legal. You cannot just distribute a cosine, just like when we were dealing with logs. You couldn't distribute the log to what was in parentheses. You had to use other properties of logarithms, right? So the same thing with a cosine. You can't just distribute a cosine. It's actually a identity property, okay? So there's cosine of x minus y. And then we have cosine of x plus y. And that one looks a little different. You've got, oh, I forgot the s right there. You've got cosine x times cosine y minus sine x times sine y. Okay? And then you have sine of x minus y. And that's going to be equal to sine x cosine y minus cosine x sine y. And then you have another one that says sine of x plus y, and that's sine x cosine y plus cosine x sine y. So you can see there's a couple of patterns that you can use to help you remember these, but really you're gonna have to know them. You're gonna have to be able to use them a lot. Okay, so this and this, all of that, you're gonna have to be able to use those to solve problems. Okay, so let's go ahead and see what type of problems we're looking at when I say we're gonna have to solve problems. I'm gonna go ahead and do an example. And let's see, we'll call this example 1. And example 1 says, find cosine of pi over 12. So when I say this, I want an exact value. I don't want you to plug cosine pi over 12 into your calculator and give me some decimal. That is not what I'm looking for. Okay, at all. Not what I'm looking for. What I'm looking for is you to take pi over 12 and take your basic common angles, and how can we split pi over 12 into two of these angles, which we know the trig values for. Okay, so I'm looking at pi over 12, and I know that pi over 12 is the same as pi over 3 minus pi over 4. So I'm going to rewrite it as that. So we got cosine pi over 12 is equal to cosine pi over 3 minus pi over 4. Right? So that right here, this pi over 3 minus pi over 4, that came from the pi over 12. I just rewrote pi over 12. And the reason I did that is because I know the exact values of those angles. I know the exact value of cosine pi over 3. I know the exact value of cosine pi over 4. So I can use those values, and I can use the sum and difference properties to help me, because this is a sum and difference property, right? You can't just distribute the cosine. You cannot just distribute the cosine. You cannot just distribute the cosine. You have to use the property. And it looks like this is the difference property for cosine. So look here, find the cosine difference property, which says cosine x minus y is equal to cosine x cosine y plus sine x sine y. Okay, so that means that cosine of pi over 3 minus pi over 4 is going to be equal to cosine pi over 3 times cosine pi over 4 plus sine of pi over 3 times sine of pi over 4. All right, so now we plug in those values of those angles, right? So cosine of pi over 3, so I'm going to go to pi over 3, cosine is 1/2. So I get 1/2, and then cosine of pi over 4, square root of 2 over 2. All right, so this is that piece, plus sine of pi over 3 is the square root of 3 over 2, times the sine of pi over 4 is the square root of 2 times over 2. All right. So now I've got to simplify that, right? I'm almost there. So this becomes the square root of 2 over 4 plus the square root of 3 times the square root of 2 over 4. Okay? So there's a couple of things that we can do. So this square root of 3 times the square root of 2, remember those can be multiplied. So we get the square root of 6, and then everything is over 4. And that would be our final answer. Awesome. All right, let's do another example. So this will be example 2. Example 2 says, find sine of 5 pi over 12. Okay, so 5 pi over 12 is not one of my common angles, which means that I'm going to have to split 5 pi over 12 so it looks like some of these angles, right? So I know that 5 pi over 12 can be broken down into pi over 6 plus pi over 4. That's the same as saying 5 pi over 12. Okay, great. And now I can use this is the sum for sine, right? So go to your identities. You're going to do the sum for sine, which was, so sine of x plus y was equal to sine x cosine y plus cosine x sine y. All right, so plug in x and y, these values, right? So sine of pi over 6 plus pi over 4 is equal to sine of pi over 6 times cosine pi over 4 plus cosine pi over 6 times sine pi over 4. All right, now we use our known angles. So sine of pi over 6, so sine of pi over 6 is 1/2. And then cosine pi over 4, square root of 2 over 2. And then we have plus cosine pi over 6 is the square root of 3 over 2. And then the sine of pi over 4 is the square root of 2 over 2. All right, so simplify time, right? So this gets us square root of 2 over 2 plus the square root of 6 over, square root of 2 over 4. 2 times 2 is 4. Plus the square root of 6 over 4, which means that we have for our final answer square root of 2 plus the square root of 6 all over 4. Yay. All right. So now I'm going to do a different type of question. This is a different example, so different from the first two. I think these are a little bit easier, so we'll see how you like them. All right, so this is example 3. And it says cosine of x is 5 over 13. And cosine of y is 4 over 5. And it says x is a first quadrant angle and y is in the fourth quadrant. Okay, and it wants us to evaluate the following. Okay, so first, it wants us to look at sine of x. Sine of x. So you're like, well, how do we do that? Okay, well, sine of x, you know that sine is positive in quadrant 1 because x is in the first quadrant, and you know that sine is positive in quadrant 1. So we're going to look at cosine squared x plus sine squared x equals 1. Remember, that's the Pythagorean Theorem. Okay, and so we want a cosine squared x, right? And that was our 5 over 13, but it needs to be squared. So instead of being 5 over 13, it's squared, so we get 16 over 25. Okay, plus the sine squared x equals 1. Now we solve. We have to, we end up subtracting 16 over 25 from both sides, and that gives us some number 144 over 169. Square root both sides, so sine of x is equal to 12 over 13. All right, so next problem, next thing they want us to evaluate is they want us to evaluate sine y. Sine y, okay? So sine is negative in quadrant 4, okay? Remember, sine is, y is in the fourth quadrant, so that's good. So what we're going to do is we are going to do the same thing, the Pythagorean Theorem. So cosine squared y plus sine squared y is equal to 1. And this time, when we have our cosine squared y, we're going to end up using 4 over 5, okay? But it's squared, which means that we have 16 over 25. Okay, so we're solving for y. So we get equal to 9 over 25, square root both sides. And then sine of y is equal to 3 over 5. Okay, but remember it has to be negative because we are in the fourth quadrant. All right, next type of problem that they're going to ask is they're going to say, well, now you've got sine of x and sine of y, that's fine. Now do some difference and sum. We want to do cosine x minus y, cosine of x minus y. So you're going to have to know those formulas, right? The difference formula for cosine of x minus y is equal to cosine x, cosine y, plus sine x times sine y. Okay, so we know that cosine x, though, we just solved for it, they give it to us. Cosine x is 5 over 13, and cosine y is 4 over 5. And we know the signs because we figured them out. Okay, so sine of x was 12 over 13. Sine of y was negative 3 over 5. Okay, so we do the math. We end up with negative 16 over 65. And that was just adding fractions together. All right, last thing that we're going to look at, and we're done. So same example 3. So all of this is still valid for this example. I just had to get you another piece of paper. We are in a room. All right, so example 3 still, but part D. Okay, what is sine of x minus y? So we've got to use our identities. So sine x cosine y minus cosine x sine y. Okay, so fill in what we know. We know that sine of x is 12 over 13. Cosine of y is 4 over 5. Cosine of x is 5 over 13. And then sine of y is negative 3 over 5. Okay, so this ends up being 48 over 65. And then the plus, because we've got the two negatives, 15 over 65. And we totaled that to get 63 over 65 as our answer. Awesome. All right. That is all I have to show for you for sum and difference identities. Thank you for watching. I would like you to go ahead and try a couple of problems. I want you to, on section 5.6, okay, and it starts on page 256, I want you to go ahead and do numbers 2 through 6 evens. And if you need help with that, it's your responsibility to ask me. So if you do need help, I'm available. All right. Thank you so much.